In this video lecture, we will solve few problems based on the fraction of emissive power. Consider a tungsten filament light bulb whose filament is at a temperature of 2860 Kelvin. If the filament is considered to be gray, what is the fraction of total energy emitted by the bulb is in the visible wavelength spectrum. Here visible wavelength spectrum means 0.4 micrometer to 0.8 micrometer. If the cross section of the bulb is of a rectangle 5 mm by 2 mm and consumes 60 watt, determine the efficiency of the bulb. Here the meaning of this statement is the filament having a cross section of 5 mm by 2 mm. Now, in this problem, the filament of a bulb is at a temperature of 2280 Kelvin. This is the filament. This is at a temperature of 2280 Kelvin. Now, this filament will produce radiations with wavelength lambda equal to 0 to lambda equal to infinity. Now, if you calculate the total emissive power of all these radiations, it will be equal to sigma A T raised to 4. If you take area equal to 1, the emissive power of the surface equal to sigma T raised to 4. This is the emissive power. Now, out of the total radiations, lambda equal to 0 to lambda equal to infinity, radiations having a wavelength of 0.4 micrometer to 0.8 micrometer will lie in the visible spectrum. That we know. The question is, what is the fraction of radiation? That means 0.4 micrometer തുടങ്ങി 0.8 micrometer വരെ wavelength ഉള്ള റേഡിയേഷൻസിന്റെ എമിസീവ് പവറും ടോട്ടൽ എമിസീവ് പവറും തമ്മിലുള്ള റേഷ്യോ. That is the question. See, for that we have the temperature of the filament 2860 Kelvin, lambda 1 0.4 micrometer, lambda 2 0.8 micrometer. This is the wavelength interval. Now lambda 1t 1144 micrometer Kelvin, lambda 2t, you will be getting this value. നമുക്ക് lambda 1t ക്ക് corresponding ആയിട്ടുള്ള fraction of the emissive power that can be taken from the data book. അതേപോലെ തന്നെ lambda 2t ക്ക് corresponding ആയിട്ടുള്ള fraction of emissive power that also we can take from the data book. See, lambda 2t ക്ക് corresponding ആയിട്ടുള്ള fraction of emissive power എന്ന് പറയുന്നത് wavelength 0 തുടങ്ങി 0.8 മൈക്രോമീറ്റർ wavelength 0 തുടങ്ങി 0.8 മൈക്രോമീറ്റർ വരെയുള്ള റേഡിയേഷൻസും ടോട്ടൽ റേഡിയേഷൻസും തമ്മിലുള്ള റേഷ്യോനെയാണ് നമ്മൾ f of 0 to lambda 2 എന്ന് പറയുന്നത്. സിമിലർലി f of 0 to lambda 1 അതെന്ന് പറയുന്നത് wavelength 0 തുടങ്ങി lambda 1 വരെയുള്ളത്, that is 0.4 മൈക്രോമീറ്റർ വരെ wavelength ഉള്ളതും ടോട്ടൽ റേഡിയേഷൻസും തമ്മിലുള്ള റേഷ്യോ, that is the fraction of emissive power with wavelength 0 to lambda 1. f of 0 to lambda 1 and f of 0 to lambda 2, these two values can be taken from the data book. Then wavelength lambda 1 തുടങ്ങി lambda 2 വരെ ഉള്ളതിന്റെ ഫ്രാക്ഷൻ എന്ന് പറയുന്നത് that is equal to f of 0 to lambda 2 minus f of 0 to lambda 1. 0 തുടങ്ങി lambda 2 വരെ wavelength ഉള്ള റേഡിയേഷൻസിനും ടോട്ടൽ റേഡിയേഷൻസും തമ്മിലുള്ള ഫ്രാക്ഷൻ f of 0 to lambda 2. This is the value. അതേപോലെ തന്നെ fraction of emissive power up to lambda 1. This is the value. So lambda 2 തുടങ്ങി lambda 1 വരെയുള്ള വേവ് ലെങ്ത് ഉള്ളതിന്റെ ഫ്രാക്ഷൻ എന്ന് പറയുന്നത് MCU പവറിന്റെ ഫ്രാക്ഷൻ എന്ന് പറയുന്നത് f of lambda 1 to lambda 2 equal to f of 0 lambda 2 minus f of 0 lambda 1. So you will be getting 0.11847. So these two values you can take from the data book directly. That means 11.84% of the total energy will be converted into light energy. Sigma T raised to 4 is the total energy produced. Out of this total energy, 11.84 will be converted into light energy or visible region. Visible spectrum region 11.84% മാത്രമേ. That is why the incandescent lamps are supposed to be considered to be very inefficient. Most of the energy will goes to the heat energy. Only 10% or even less than that is converted into light energy. Now the next part of the problem is, what is the energy emitted in the visible light spectrum of the bulb with a specification of the filament is given. So total energy emitted equal to sigma into A into T raised to 4. Sigma is known, T is known, area of the filament has to be calculated. Area of the filament. Here one rectangular shape is given. So both sides, thickness is very small. So both sides we will be taking. So area of one side equal to 10 into 10 to the power of minus 6 meter square. So area of both sides into 2. So light energy emitted equal to sigma A into T raised to 4. This is the total energy emitted. Out of the total energy emitted, only 11.84% is converted into visible light. This will include heat energy as well as light energy. Idinte 11% മാത്രമാണ് light energy ആയിട്ട് convert ചെയ്തുള്ളൂ. So the energy converted into light energy is sigma A T raised to 4 into 0.11847. This is equal to 8.91 watts. So here it is said that 60 watt bulb. Out of the 60 watt energy we are providing into an electric bulb, only 8.9 watts is converted into light energy.